Welcome back, everyone, to DC Thursday. I'm Pete Soderling. I'm the founder of Data Council and Data Community Fund. And we have another amazing guest lined up today in our series of interesting people who have been foundationally instrumental and helpful in building the data ecosystem. And today, I'm excited to have Julien LeDem with us. He's the co-founder and CTO of Datakin currently, but Julien has also been involved in some instrumental projects that we all know and most of us use. He's the co-author of Parquet. He's been very involved in the development of Apache Arrow as a PMC member. And previously, he worked at WeWork, at Dremio, as a staff software engineer at Twitter, as a principal engineer at Yahoo, and he studied math, physics, and CS in France. So Julien, I want to welcome you to the show, and thanks for being on with us today.
Well, thanks for having me.
So the first question that I just wanted to ask you, and I hope this is okay, is you've been in the industry for so long. I think you came to the US maybe in 2006 or 7, is that about right?
2007, yeah.
2007. So you've been involved in so many instrumental projects. I was just wondering why it's taken you so long to start a company in the data world.
Well, yeah, I think, it's funny. At the same time, it took a long time, but it feels like everything I've done so far kind of led into this, into building a data platform, building open source projects, and really creating communities and becoming part of this community, of this data community, and understanding it better. It's kind of all led to that point in really how do we solve, depending on each other, and like operating data platform and data pipeline at scale. And when I say at scale, it's not like just big data scale, like a lot of data, but it's really today is like organizational scale, right? Where you have lots of teams and people depending on each other, producing and consuming data. So it kind of, I feel like a lot of things that I've done in the past led to this point, and it's kind of because I've been involved and because I've started open source projects and I've helped grow others that I got there, right? It's kind of how I see it.
Well, definitely it's a blessing when you see that your career when you look back over your shoulder and you see that your career has had a series of steps that have actually been joined to an apparent productive and I know the feeling, and so I'm glad that you have that sense as well. So let's talk about some of these key moments, because I find in my conversations with founders that it's often understanding what those key moments were and what the key insights were along their way in their career that definitely have sort of led them to where they ended up during our conversation. And so we're going to have some awesome chats later about open lineage, metadata, some other things. But you have such an amazing journey from company to company that were significant in the data space. I just wanted to stop along the way and chat about some of those experiences. So maybe we can start at Yahoo, because I think Yahoo was likely your first meaningful data job, if I'm not mistaken.
Yeah, that's correct. So it's like the company I was working for back in the day got acquired by Yahoo. And so I ended up working for Yahoo. And so in 2007, I moved to the headquarters and I joined that team who was building platforms on top of Hadoop for the more media companies of Yahoo. So, like Yahoo Shopping, Yahoo News, Yahoo Movies, Yahoo Autos, a lot of those things. So they do a lot of collecting listings or news article or used cars listings or different things like that. And so there's lots of text processing, matching product to catalogs, matching, extracting entities for news articles and bringing structures to all those listings and these articles or like movie description and bringing that structure, and that kind of help build this guided navigation and that you'd find in a shopping comparison engine, for example, and so on. So it's kind of building a generic platforms for those kinds of properties on top of Hadoop. And of course, at the time, Yahoo was kind of the place to be to use Hadoop, right? That was really the beginning of Hadoop. And I remember
Mm-hmm.
seeing, I was in the same building as the Hadoop team at some point, and seeing Hadoop team members with a T-shirt that was saying in the back, scaling Hadoop to 20 nodes, right? You know, with a
Mm-hmm.
chart that was going up and to the right. And it was like 20 nodes, yahoo! Um, so those were the days. And of course, like over those 4 years, that was maybe an old T-shirt already at the time, but it's kind of course, it was like thousands of nodes
Mm-hmm.
by the end of it. Um, and so at the time we were building, how do we do batch processing and this transformation and this enrichment on top of Hadoop? And it's kind of, you end up with many teams, consuming and producing data. You have like these different properties and different teams depending on each other. And you start thinking about, how do we apply the service-oriented architecture principles for this kind of batch processing? Because now the interface is not a service API, right? It's a data set, right? The interface is a data set, and the data sets at the time, they are shared in a distributed file system. You have the Hadoop distributed file system, and so there's a folder somewhere in a shared file system that is shared with some other team. And if this is the only thing you do, and you say, oh, people write files to the file system and share it with others, it becomes a big mess, right? You need ways to coordinate, to trigger a downstream consumption when a data set is updated, all those mechanisms that now we're kind of more used to with workflow engines and such. And so for me, that was the beginning of thinking really, okay, how do we define those service-oriented architecture principles? What are the interfaces? How do we depend on each other? How do we trigger downstream transformation? How are we aware of updates of data set? And that's kind of things that started this. And also, at the time I started contributing to Pig, because at the time, we were still writing raw MapReduce jobs at the time, and Pig was a better MapReduce. And Pig has kind of lost momentum since then. But at the time, it was a better MapReduce. It's kind of the niche that Spark took over now. Now Spark is the better MapReduce, and it's kind of really outlasted every other competitor in that space.
Yeah,
so
got it.
At the time, Pig was big, and there was a strong community around it, like in particular with obviously Yahoo, who started the project, Netflix, LinkedIn, and Twitter. And it's kind of, that's what led me to my next job, right? Like I became a Pig committer. That was my first committership on the Apache project.
Because you went to Twitter next, right? And then you worked in the data team at Twitter in maybe 2012-ish or so?
2011.
Okay.
I joined Twitter end of 2011. And that was through this community, right? Through the Pig community, I had met the data teams at Netflix, LinkedIn, Twitter, and I decided to join Twitter at that time. And so at Twitter, yes, I joined the data team. So in that sense, that was more the traditional way people think about big data. They think about time series. We know about how people are using our product, what they click on, what they search for, and things like that. And so lots of time series data, everything collected on Hadoop. And at the time, Twitter had Hadoop clusters that were able to store a lot of data. But of course, when you run a Pig job or a MapReduce job, you go take a coffee and you come back later, right? So it's kind of optimized for throughput, but not for latency from the user perspective. So it's kind of can process a lot of data, can store a lot of data, but it's kind of slow iteration for analysts or data scientists or people kind of trying to figure out what the data is. And they also add Vertica, which is a data warehouse. So it's more like SQL, lower latency, but of course it didn't scale as well as Hadoop, right? So it would always have a fraction of the data. And Vertica
but it had columnar analytics.
Exactly. Vertica
right,
is
Vertica.
And so, I was working on top of the Hadoop side of things and helping people with Pig, and it's kind of, and looking at Hadoop and raw-oriented storage, and it's kind of high latency and Vertica, but that didn't scale as much, but was lower latency, better experience. And so that kind of led into Parquet. So I started prototyping something, and from my work at Yahoo, I was already aware of the Dremel paper. And I had been, when I was at Yahoo, I had been thinking a little bit how that would have been useful for us at that time, but I didn't really get to kind of further than thinking about it. And at Twitter, I really dug more into it and really, okay, how do we can we bring more of the Vertica properties into Hadoop? How can we make Hadoop more like Vertica, and it's kind of and getting the lower latency, the better response for queries, and so on. And that's kind of, I started prototyping something and implementing. So the Dremel paper has two parts, right? There's the execution engine aspect, and then there's a storage layer file format that they describe. And so I started like implementing the algorithms that were described in the paper. And so that's kind of led to, I had the beginning of something, and I reached out because I knew I didn't want to build something proprietary to Twitter, and that we would have to integrate with everything, and that wouldn't make any sense. So I reached out, and that's where I connected with the Impala team at Cloudera, and they were prototyping a columnar format as well for Impala, because I mean, they were kind of following the same train of thoughts, right? It's kind of like that made sense. And so we joined forces, and it was a great collaboration, because Impala being all native execution, native code execution, for them, it was getting all the JVM ecosystem. That this collaboration, I kind of brought all the JVM implementation side of things. And for me, like building this, it brings the validation of an actual, columnar query engine on top of it, right? It's kind of not just, because I was hooking that up into Pig and cascading, like we're using scalding that is built on top of cascading at the time, so that we could support the Twitter use cases. And then they brought the query execution, fast query execution use cases that brought a lot of validation to the format. So we joined, it's kind of, we merged designs, some of the design aspect I brought, some of the design aspect they brought, and that made the success of Parquet, I think. It's kind
and
of,
you open sourced it, and it became an open standard.
Yes. And then originally it had different names, so we each had a name, and we kind of brainstormed a new name, and that became Parquet.
What were the names?
So on my end, it was called Red Elm.
Red Elm.
Red Elm, and it's an anagram of Dremel.
Okay, right.
So that's what I was going for, but I was I was thinking, oh, we do the whole thing, right? But actually, I think it made more sense to kind of like focus on the file format and like enable the ecosystem. There were like so many SQL and Hadoop projects happening at the time. I think that made a lot of sense to have like a common storage layer for them, rather than building yet another one.
Got it. So you stayed at Twitter for a few years, and then you ended up probably with your closest brush, maybe to date, at starting a company, I assume. I mean, you were a very early team at Dremio, right?
Yeah, I was on the day one at the starting of Dremio, so really can't start in so part of the founding team at Dremio, and so Dremio was kind of going at it's and Dremio is very successful since then. It's there's on one aspect of it is the federated query engine that lets you query all your data where it is, and it has the ability to materialize some of the transformation, so it can, like, it has a smarter optimizer that can take advantage of that to speed up your queries. And the idea is, look, you plug your Tableau to your data lake, and you get the same experience than if you used a more data warehouse or a cube or something, without having to worry about importing all your data, like selecting what subset you put in your data warehouse, like we were doing at Twitter. And I think this was really related to all the work I had been doing on Parquet, and how do we optimize query. Like part of it was the storage, and thinking about the optimizer, and it's kind of the wider query processing aspect. And as part of that, that's how we started Arrow projects, right? So it's kind of, as part of this Parquet community, the next step was to start discussing, how can we have in-memory columnar representation. So we have, as Parquet, we have an on-disk columnar representation, but we also need an in-memory columnar representation. And it's a different project because you optimize things differently when you optimize for pulling data from disk or whether you optimize for processing in-memory really fast. So really the criteria for like the layout are very different. It's still a columnar representation, but how you pick encoding and all of that is very different because of the different characteristics of disk and memory. And so that kind of, different people got connected. Like, so Dremio was started by the creators of Apache Drill, which SQL and Hadoop, and they had an in-memory columnar representation. And the Impala people are saying, oh, we need an in-memory columnar representation. And so in some ways that connected people, and we started a larger group. And we say, okay, so how do we do this together? And so we decided, basically, Arrow started as spinning off this columnar representation in Drill and refining it based on everybody's use cases. But we started by doing a kickoff by reaching out to a bunch of people who had this use case, right? Like, so you had the Impala people, Wes McKinney from Pandas, who was very interested about this. You had the Dremio folks and Drill. So we contributed to that. I kind of represented also the Parquet community in this aspect. And now Parquet and Arrow is very well integrated together. We can Pandas really fast, for example, or Dremio really fast, or others. It's integrated in Spark now. BigQuery returns Arrow result sets. And also BigQuery, it's interesting because BigQuery both can consume Parquet and can produce Arrow result set. The reason they're doing that is because, of course, you can load your BigQuery result sets faster in Pandas because it loads it in Arrow.
Well, that's a great story about how you got the community together around this format and this sort of across the industry, right, from multiple companies. It's neat that you were essentially able to do that twice, once with Parquet and then again with Arrow.
So to be fair, Arrow piggybacked on the Parquet community as well, right? We didn't start from scratch, but it's kind of, I think, yes, it's an iteration of like how we build communities, and it's not exactly the same one, but I mean, the motions are similar, right? How do we build something together? How do we own this together? And how do we make it happen as a community?
And so next you went to WeWork, and which surprised me a little bit at the time, I have to say. I have to be totally honest. But I know WeWork was building an amazing data engineering team, and they had big visions for what this team was going to accomplish. What was it that you learned at WeWork, and sort of how did your career take the next step there?
So at WeWork, I think I switched gears a little bit because I became basically the architect for the data platform. And that was the time where WeWork was growing exponentially, right? So when I joined, there was relatively little data platform. There was Redshift and some in-house scheduler, and data was getting imported in Redshift, and that was it. But in that phase, there was growing a lot. And so as part of introducing in the ecosystem, there was like, how do we ingest event into Kafka and enable collection of events at scale, right? Rather than just importing the data that is already in the production system. How do we enable stream processing and batch processing, but working together, right? How do we define a nice storage layer, using more modern way of storing data in files like Iceberg or Delta Lake. And at WeWork, we picked Iceberg at the time. So it's kind of creating this nice foundation, and so a much more generalist role in that case, I mean, from the data perspective of understanding what's a data platform, how do you put streaming, ingestion of that data, stream processing, batch processing, storage layer, whether it's streaming or data in motion or data at rest, and BI and machine learning, right? It's kind of like enabling all of that, making sure schemas are defined, people understand how they depend on each other, and so on, right? And while building that, a lot of this was, okay, what do we pick? What's the best of breed existing open source project for each of those components? Like, so picking Iceberg for at-rest storage in S3, picking, Spark for batch processing, Snowflake for the warehouse, and things like that, and making sure everything connects well together. And I think one of the big piece that was missing in this ecosystem is this metadata management, right? Like, it's kind of, how do we have a lineage and metadata repository so this doesn't become a mess, right? We know what all the data set that exist, all the jobs that exist, how everything depends on each other, so that teams have visibility, right? You have many teams in the company that consume and produce data, and they depend on each other, and they need tools to understand how they depend on each other and understand that they're not going to break anything, or if they break something, they're aware of it and they know how to fix things quickly, right? Like, to be agile and be able to move fast as an organization, you need to have visibility in what's happening. So that leads to the creation of Marquez. And Marquez is this lineage repository, lineage and metadata repository that keeps track of everything that's running, all the updates to data sets, and all the dependencies, right? How everything depends on each other. So it's kind of, that was the core of this, and like enabling this data platform.
So I wanna drill into this because I think we arrived at one of the key concepts that we want to talk about, and so I want to make sure that the listeners understand fully what you mean by metadata and data lineage, and also like what the implications for those concepts are, because I think they're things that we're starting to become slightly more familiar with as an industry, but I'd love to hear it from your words. If you could just tell us like what is data lineage and what does it mean?
So it's interesting because I think depending on who you ask, you'll get very different answers to what is lineage, right? There's like one of the concept of lineage is like, I want to understand how this data set is derived from others, right? Like, oh, this column here's the expression that produces this metric, or how this value is derived, and what table is derived from. And from a certain perspective, it's very static. It's caring about what's the current state of the system, how is this column derived from another one, and that's one common definition of lineage. Another way of looking at lineage is really to understand how that changes over time as well, right? So I think that when you look at lineage only from dataset to dataset perspective, you actually lose track of a lot of the metadata and what's happening. Because a dataset, especially in the data world, exists because it's being produced by a job, right? And like the runtime characteristics of that job and how that changes over time are really important to understand how that affects the dataset. So in terms of, when we think about the lineage that is stored in Marquez, it's trying to be very granular and to keep track of every run of a job. And for a given run of a job, let's say you have a recurring job that runs every hour, right? So a run would be the hourly run of that job. And you know what version of the dataset you consume, what version of the output dataset you produced, what was the schema of the input and output at the time it ran, how long it took, what was the version of the code, if it's stored in Git, what was the Git SHA, what was the query profile, statistics around performance at the time, you can store what were data quality metrics and assertion if you run like data quality libraries on top of your output at the time. And you store that. So now you have lineage, but it's really at the run level, or if you look at the data perspective, it's at the dataset version level. So you can see over time how has the metadata changed on the dataset. So something that come in mind, or if something's broken, you can care about when did the schema change, what did it cause downstream, what caused the schema change upstream. Maybe someone changed the logic somewhere. Or you may care about data quality metrics have changed. Suddenly we have a drop in row count, or we have an increase in null values in a column, or the distribution of this became very skewed suddenly. And and you can keep track of not just how that changes over time, but really connecting that to which run of the job caused that change, and what
And you're
changed
saying
that
that
job was predicted.
you're saying that that's absolutely required because having an operational view of like how the data is being transformed multiple times in the system over time is key to understanding the full lineage of that data. It's not just about like this column is driving some other column in some other data set somewhere. It's like if you don't take into account the operational changes and processing around the data, then your data lineage is incomplete anyway. It sounds like
Exactly.
that's the discovery that you had.
Yes, and I think that's one of the reason we built Marquez, because there were existing lineage solutions in the market, right? Like a lineage open source project and things. But often what they did is they focused on a specific use case, and they collected the metadata they cared about for that specific use case, and dropping on the floor a lot of the informations we cared about. And I think one of the findings of this is like by having a really fine-grained operational metadata, of course, once you know about how a data set is connected to a job, is connected to another data set, you can transform this to remove the job, right? And get the data set to data set lineage and feed that into a system that needs that to present other kind of perspective on data lineage. And so you can turn the more fine-grained lineage into like data set to data set lineage, but you cannot do it the other way around, right? So it's kind of was really important to start collecting at the right granularity, keeping the metadata about the job, really understanding how things get transformed. And because that informs figuring out all the problems we might have with our data.
So can you give us an example of like what's a common problem that could be solved if a company had access to proper data lineage that they might not even think of in those terms yet?
Yes. So I think, people care a lot about data freshness and data quality, right? And so you see a lot of solution that come out to solve that from a monitoring perspective, right? They care about, so when you talk about data freshness, there's two root causes to that. One is something's broken, so it's not running anymore, and therefore the data set doesn't get updated anymore. And second, everything runs slower than usual, and the data set gets updated, but it gets updated very late. So there's kind of this freshness problem. And from a data quality perspective is the data is wrong, right? And it could be same thing. There's been a problem at some point, someone pushed a bug, or there's bad third-party data that has been ingested, or something happened that creating this skew in the data or something. And so when you talk about data freshness and data quality, there's a lot of things, a lot of explanation that focus on monitoring that. How do you know if your data is correct or not? How do you know if your data is up to date or not? And so that's great, right? That's about being aware when something is wrong. But the very next step, once you know something is wrong, is you need to figure out the root cause of the problem. And the root cause of the problem is extremely rarely in the data you're monitoring itself. The root cause of the problem is almost always upstream from it, right? So you may be looking at your executive dashboards that executives in your company like consult every morning before the breakfast, and when it's broken or it's wrong, this is bad. But what you need to understand is all the lineage upstream that leads to this dashboard. You need to understand whether a third-party data ingestion that it depends on caused the problem. You need to understand if any change in the data pipelines in between the ingestion of data and the delivery of the dashboard is problematic or is failing for some reason. So really this operational lineage or really detailed lineage of everything, how it changed over time, is really key to understanding why things are slow, why things are incorrect, and fixing it quickly. Because I think that the main problem, it takes a long time, because when you start looking at your data, then you see the current state of things, and you don't know, or it's really hard to figure out what has changed when in correlation with their output data being bad or starting to become very slow to show up.
So you're saying that lineage is the key to a lot of common data problems. And I think you also commented on a shared observation that I've seen in a bunch of the companies that I invest in as well. It's that, many of these companies sort of, they want to solve a particular problem, right? Data quality or, monitoring or performance of some kind. But they end up sort of backing into their own representation, data cataloging, but they sort of back into their own representation of, metadata as far as they need it for their end solution. But didn't start with metadata or didn't start with lineage. They sort of start with the problem, which is a valid place for any founder to start. But it seems like they all start to many of them start to converge into the similar sort of, necessary needed backend where they're tracking lineage and metadata to the extent that their product needs access to it. And so it's been interesting to see the data ecosystem sort of emerge along that pattern in the last couple of years. And it seems like you've seen that as well.
Yes. So, I mean, it's key to understanding the root cause of the problem. And the next thing that's really important is start preventing problems altogether, because you can identify upstream of lineage to find the root cause quickly, but you can also leverage downstream to prevent, before you're going to push a change to production, you can validate whether it's going to break something downstream or not, right? Like, because you understand dependencies. And it's really key to, we talk about data pipelines reliability of making sure you can trust your data, like that the data is delivered on time and it's correct. And a lot of understanding lineage to me is really core to enabling that and being more efficient and avoiding being in this state where everything is always broken, or worse, you don't even know if it's broken, or you don't know what to fix first. And so understanding lineage, and what impacts what is really critical to that.
Yeah, I totally get it. So if lineage is so key and if it's such a panacea for many of our modern data problems, why is it so difficult or challenging for companies to implement some sort of solution in this area? Like what are the main pitfalls and the hurdles that you see?
So I think a lot of the lineage solution that we see in the ecosystem, they focus on how do we extract lineage from all those systems? Like people might be using Spark, they might be using warehouses, they might be using a lot of pandas, a lot of different systems. And so they start focusing on how do I extract lineage from each of those things? And they start depending on all those projects and the internals of all those projects, and really starting being intimately dependent on all those things. And it's very complex. There's a lot of work to do this. And second, it's also very brittle, because as this system changes and you depend on their internals, they're not usually part of the official maintain contract that needs to be backward compatible. So all those lineage integrations, first, they're expensive and complex to build. And second, they need to be maintained and they need to be re-implemented and fixed over time. And then you have to deal with the complexity of not just maintaining for one version of Spark, right? But like for 3-4 versions of Spark, like 3-4 versions of Airflow, and all those things evolving in parallel. And there's a lot of complexity to all of that. And so it's kind of, that's kind of what led to, starting open lineage. And so I think like the conclusion was, we really need to solve that in the open source, right? And it's not just like, I think we as engineers, we have a tendency to kind of look at systems and see, oh, I can read the code, I can understand this, and I can reverse engineer it and like produce lineage from it. But as people, we actually need to talk to each other, because that leads to very complex solution to kind of avoiding talking to others and just figuring out by yourself. And how do we define a standard so that instead of everybody kind of trying to pull the lineage out of the internals, it's like each project can actually publish their lineage in a standard way and simplify this problem, right?
So wait, I think I see where this is going. Julien is going to talk to other people in the community, and for the third time in his career, he's going to work to create an open standard around lineage. Sounds like, I think you just let the cat out of the bag, but it sounds like it's actually called open lineage. So tell me if I'm wrong.
Yeah, so actually, we started that end of last year. So it's kind of, and really, you're right, right? I took a card out of the Arrow playbook, and there was this conclusion. It was like, look, each, there's a need for multiple product that exploit lineage and like present it for different use cases, whether people care about data catalog, they care about operation, they care about governance, compliance. They all need lineage, but they have different use cases. So they need different solutions on how to look at that. However, the lineage collection and like having this fine-grained understanding of dependencies, this is all widely applicable and everybody needs it. And it would be much easier if we could define a standard and we could say, well, this is a standard way people expose lineage and consume lineage. And so that instead of having this complexity and maintaining different integration for each of the projects that care about lineage, we can just like have a standard and, it removes duplication of efforts and everything is less brittle because each project can actually expose their own internal in a lineage or metadata in a standard way. And there is a standard way of doing that we maintain, and it's not changing all the time, right? So we did like Arrow, right? We kind of started reaching out to people in the community that were interested in that kind of thing. And like 90% of the project we reach out to were like, of course, we need a standard lineage, right? Like how come does it not exist already? Like it's been like, I don't know, like 15 years from my perspective. How come we don't have a standard lineage yet? Well, the thing is, for it to happen, we need to plant the seed. We need to come together and say like, okay, let's do this and push it and create a focal point where we can standardize this and make it happen. So that's what we did. So like Open Lineage, we started kind of like relatively small community, reaching out to people from DBT, from Airflow community, from Prefect, from Pandas, from Spark, from Data Hub, Amundsen, Egeria. It's kind of reaching out to, and Great Expectation, and I apologize, I'm like forgetting people. But like getting together and talk about what's the right way to do this. And started Open Lineage. And actually last week, it's also officially been submitted to the LFAI and Data. So this is the sub-foundation of the Linux Foundation, like the sister to NCF. But so it's like the CNCF for Data World.
Okay, great. That's great. That's a very cool development.
Yeah, so it just happened. So it's like, it's like Arrow. The goal is it's not a project that is owned by anyone. It's really something that we need as an industry, as a data ecosystem. We need to have a standard way to do this. We need to build that together. And the more people contribute to it, the more everybody gets out of it, right? So
that's great.
Good open source motions, I think, for that kind of project. That helps build momentum and creating this open source flywheel of getting adoption, like you've seen in Parquet and Arrow. It's kind of like there's lots of value of trying to build those standards in open source.
We just added a link to the Open Lineage project in the YouTube chat so that folks can check it out. So before we talk a little bit more about, in depth about some of the architecture and design principles of Open Lineage, I just wanted to clarify one thing, because I know that you were working on Marquez, which was, sort of an original data lineage project at WeWork. And you and Willie have spoken about that at Data Council in years past. So I just want to understand, sort of generally speaking, what's the difference between Marquez and the new Open Lineage project, just so that we create the right space in people's minds in terms of comparison contrast.
Yeah, so Marquez is a lineage repository, a lineage and metadata repository. And as I mentioned before, one of the findings is there are very different use cases to inspecting lineage or presenting lineage, like whether we talk about governance or data catalogs or different. And each system really wants to be able to store it and index it in the way they care about, right? Depending on their use case. Or people care also about privacy engineering is another use case that people care about. And so, and there was this conclusion that, oh, there's many projects that care about extracting lineage from other systems. And so there's lots of duplication of effort, and this is hard, and so on, right? So open lineage, it's really, and it's kind of came from the realization of we need something like open telemetry, but for data pipelines. So open telemetry is a CNCF project, and what it does, it's standardizing metrics and traces and log collection for services, right? Like in traces for services is really similar to lineage for data pipeline, right? Except though, of course, like services and data pipelines work differently. So you need kind of its own API. But there's a strong parallel of defining a standard for collection that then can be leveraged by many tools, whether it's open source project or third-party vendors or various other things. So really open lineage focused on just defining the standard for collection of this lineage. And then you can have multiple consumers, you know, and Marquez is the reference implementation of it. So Marquez is open lineage consumption endpoint. And open lineage is an API on how you emit and consume those open lineage events so that you understand really at the run level and very granular lineage information. So it's kind of, that's what open lineage is. Open lineage is a standard for lineage collection, and Marquez is a reference implementation. And of course, there are others who working on implementing open lineage.
Got it. Okay, that helps. Yeah, thanks for clarifying that. So what are some of the core design principles of open lineage? Like, how do you go about thinking through how to build something like this?
Yeah, so I think one of the goals from my experience building those open, you know, standards in open source, and it's kind of, it's a bit different. Like we're not like a standard body, right? Like it's not like there's not a bunch of people that have been appointed and they kind of meet months and kind of work for a long time on having a big monolithic spec. So really the idea is in open source, it's really good to decompose every atomic decision, like really have their own conversation and their own life cycle. And you really want to avoid have a big monolithic spec that defines everything. And so what we did, so starting with this core group of people who were excited about like working on open lineage, we started with making this core spec, which is really what's the minimal thing we can define that collects lineage, and how do we make it extensible so you can add various pieces of metadata that different people care about for various use cases, right? So the core model of open lineage is very simple. There's a notion of recurring job that is identified by a unique name that's running, like your typical hourly jobs or daily jobs or monthly job, but it can be various other things, right? There's a notion of run. So there's a run ID of like, this is an instance of this job running. And then there's notion of inputs and outputs. So you have a run of a job that is reading from this input data sets and writing to this output data set. And same thing, having it has a consistent naming policy so that we can stitch this lineage back together, and like two different systems will call this data set the same thing. And so this is the core, and it's just capturing the lineage, and it's very simple. And so that's the first thing we did as a group. It's like, let's solidify this. This is the core. And on top of that, there's this notion of facet. And a facet is kind of an atomic piece of metadata. So each facet is its own little spec, right? It's all defined using JSON schema to specify what the fields are, what's the representation. And so you can attach facets to the job, to the run, to the data set. And so on a data set, for example, it could be the data set schema at the time the job ran, right? So you can track whether the schema has changed and what ran changed the schema. It could be data quality metrics at the data set level. You know, what was the row count? What was the number of null count for each column, like, or distribution or things like that, if you implement something like Great Expectations, for example. And then at the run level, you make stores things like what's the query profile for this particular run, how long it took, what was at the job level, which could capture what's the version in source control of the job and keeping track. So you can start correlating, changing the output schema with what was the version of the job, and stitching back the lineage together. So it's kind of
the facets. So if there's three core types, there's job, run, and data set you mentioned, and then the facet can be added to any one of those three to sort of further define specific metadata for that particular instance. Is that the general idea?
That's a general idea. And so the core model is very generic. And the idea is also, so first, you can add optional metadata depending on the context that may or may not be available. You may or may not have a schema depending on what you have. And also you have different types of data set, right? A data set could be a folder in an S3 bucket. It could be a table in the data warehouse. It could be a topic in a Kafka broker, right? So it's kind of, and depending on their type like this, they will have different facets, right? You have different piece of metadata. You track differently what was the version of the data set from one to the other, right? If you use the version data storage, like a Delta Lake or Iceberg, for example, you can keep track of what actual version was produced by this run, right? Which lets you really easily roll back using time travel, like the features those storage layer provide, to roll back to the previous version if something goes wrong, right? The worst case scenario is not when the job fails. The worst case scenario is when the job ran, produced bad data, and it propagated all through your stack, right? So that's kind of like the kind of thing you can track through that.
So what's the result of the project been so far? How are you measuring success, or are you aware of how many folks are adopting the core principles behind Open Lineage so far?
Yeah, so the progress so far, so we defined the initial spec. We started defining facets. So we have some core facets that are defined. And Marquez, of course, is a reference implementation. So anybody who want to consume Open Lineage can use Marquez for this. We have integration. So it's kind of, the goal eventually is to be pushed in every project as a dependency. And it's like just adding an interface, right? And you can emit information to it. And it's not like, it's relatively easy to integrate because it doesn't add any other extra dependency to your project, right? It's just an API with no dependencies. And it's like a logger, really, like perspective of like tracing library. And so we have integration at the moment for Airflow, for BigQuery, for Spark, for Snowflake, Great Expectation, and there's a prototype of like dbt integration. On the consumption side, I think the most advanced project is the Egeria project. So Egeria is this open metadata project. And so they'll be working on also being able to consume Open Lineage and be able to also write it. So it's kind of, Egeria is a bit like a metadata bus that lets you kind of push your metadata to other things. So it kind of makes sense to be able to consume and produce Open Lineage and connect things together as well. And the other aspect of Facet that I didn't mention, so one of the goals is to remove friction from the project, right? Like, so avoid having tightly coupled decisions, right? Like decoupling, facet decoupled decision making. And so we can move fast on things that are less controversial, and things that are more controversial can have more focused discussion and like get to a conclusion. And the other thing we added is this notion of custom facet. So actually, anybody can attach a facet that is not part of the spec and publish their own definition of a facet. And the idea is it makes it really easy for people to experiment and like create their own facet without having to go through getting it approved by the project, right? Like you can really make your own facets and be able to add to it. And I think there are two values to this. One is kind of really unblocking people as much as possible. They can experiment with it without to ask for permission for anything. And second, it's a great way to collect what people are doing with it, to kind of start bubbling up more standard way to represent certain things.
To the actual spec, right?
Yeah. So
that's really cool. Those are some really interesting design principles. Um, yeah, that's great, Julian. It sounds like a really interesting project. I'm curious, like, if somebody wants to dip their toe in the water with Open Lineage, like, what's the quickest, easiest way to get started? Because sometimes I think the fear behind these kinds of projects that have like such a strong sort of philosophical or opinionated bent is like, do you have to commit whole hog to it to actually get value from it? So like, what's the best way for people to think about that and that trade-off? Like, what does that look like for Open Lineage? What's the smallest way to get started?
So I think the easiest is probably to stand up a Marquez instance, right, and start collecting Open Lineage. So you can use the existing integration. So if you use Airflow, if you use Spark, if you use BigQuery, Snowflake, you can start like hooking that into your Airflow and sending Open Lineage event to a Marquez instance, for example, and see the lineage. And Marquez also has a lineage API that you can script it as well, right? You can query the REST API, and there's a GraphQL API for people who like this kind of thing to kind of explore the lineage or build on top of it. And if you want to integrate things that are not integrated yet, right? Like, so there's a JSON schema spec that is relatively easy to use. And we have a Python client and a Java client in the works, which makes it easy. So depending on if you're interested in introspecting what you have and see in Marquez what this looks like, or whether you're interested in making your own integration, right? It's all about producing JSON events. And there's clients that help you doing that, right? So once you have JSON schemas, really JSON schema is the underlying object representation for OpenAPI, for people who are used to OpenAPI and generating code for models and exposing like this. It's a relatively easy way to push the model, right? So we have a Python client that's based on that, and a Java client that lets you easily produce your metadata in that space.
Got it. And of course, people can find full documentation on GitHub, and they can get in touch with you. You have the illustrious @J_ handle on Twitter that we always hear about in the community. So I'm sure, is there a Slack group for Open Lineage or any community like that?
The best way to reach out is probably to join the Slack channels. So if you go on Open Lineage GitHub, you'll find a link to the Slack, right? It's Open Lineage Slack, Open Lineage Twitter handle, the Open Lineage GitHub organization. So it's relatively easy to find. So please join the Slack. Feel free to ask questions. Yeah, we're very happy to help and answer questions. And there's some focused discussion channels as well in the
Okay, great. Yeah, that's good to know. Well, Julian, we're almost out of time, but I just wanted to ask you a final question, which is, what are the big insights that you've learned over your career working with data?
I think like working on those open source, maybe I'll reuse some of those analogy, like engineers like to reverse engineer stuff more than talking to others or like spending time figuring out. And so I think that's kind of one of the key finding, and that Open Lineage is a people problem more than a technical problem. It's about getting together and agreeing on some key principles and like making it so much easier to build these things, right? So I think there's this notion of stone soup, right? I don't know if you know this stone soup children's story. Like someone comes to our village and they go on the main town square, and they have a big pot of hot water, and they put a large stone in it, and they start stirring it, and like people ask them, "What are you doing?" "I'm preparing a stone soup for everyone, but you're welcome to add your own ingredients." So basically, they're making a soup of nothing, right? It's just hot water, and the stone is just like a dummy thing to say, look, I put an
Mm-hmm.
ingredient and I start steering. So I'm just enabling the community, right? And people bring their own ingredients. I was like, okay, let me add carrots to it. Let me add leeks to it, whatever. And I start steering. And the more people contribute to it, the more this thing becomes better for everyone. So it's kind of, that's what I'm doing. I'm steering the pot. And I think there's so much you can achieve by enabling others, right? How do we get together? How do we own this as a community? How do we make it make sense for all of us? It's kind of, building this open source momentum, right? Like, and the more people contribute, the more there's value into it, the more people contribute. And, you've seen that happening for Parquet, and you've seen that happening for Arrow. And yes, it takes years, but it happens, right? And once it started, it's kind of unstoppable, right? Like, today, if I wanted to stop Parquet, I couldn't.
How? Yeah.
There's nothing to do about it.
Yeah. Well, that's really well said, poetic even. And it's been great to collaborate with you through Data Council over the last few years. We've definitely appreciated you coming and sharing in forums like this and at our live conferences. So it's been great to get to know you, Julien, and I appreciate you stirring the pot. I hope that you keep it up. You're right that engineers aren't always good at sort of building talking to each other and sort of using collaboration to build standards like this. So yeah, thanks for all your work in the community. And it was really great to have you chat with us today.
You're welcome. It was a pleasure. Thank you. Have a great day.
And to the rest of the community, thanks for joining us. Please subscribe to the YouTube channel so that you can stay abreast of some more amazing DC Thursdays episodes that we have coming up across the summer. So take care, and we'll see you soon.